Welcome to this channel. In this video, we will derive the solution of sine-Gordon equation. And sine-Gordon equation is partial square u over partial x square minus partial square u over partial t square is equal to sine u. And sine is dependent variable and x and t are independent variable. First of all, we will substitute eta is equal to x minus vt to transform this equation into one independent variable. So, partial eta over partial x is equal to 1 and partial eta over partial t is equal to minus v. And partial u over partial x is equal to, now we will use chain rule, so this become partial u over partial eta and partial eta over partial x, and partial eta over partial x is equal to 1, so this become partial u over partial eta. Now if we take again derivative, so this become partial square u over partial x square is equal to partial square u over partial eta square. And partial u over partial t is equal to, again we will use chain rule, so this become partial u over partial eta over partial t, and partial eta over partial t is equal to minus b, so this become minus b partial u over partial eta. Now we will again take derivative, so this become partial square u over partial t square is equal to partial over partial t multiplied by minus b partial u over partial eta. So this become minus b partial square u over partial t partial eta. Now again if we use chain rule, so this become partial square u over partial t square is equal to minus b partial over partial eta multiplied by partial u over partial eta and multiplied by partial eta over partial t. Again partial eta over partial t is equal to minus b, so this become v square partial square u over partial eta square. This is equation number 3. Now use equation 2 and 3 in 1. So this become partial square u over partial x square is equal to partial square u over partial eta square minus, and partial square u over partial t square is equal to v square partial square u over partial eta square. V square partial square u over partial eta square is equal to sine u. This is equation number 4. Now we have convert equation 1 into single independent variable, so we can transform partial derivative into ordinary derivative. So this become d square u over d eta square minus b square d square u over d eta square is equal to sine u. Now we'll take common d square u over d eta square. So above equation become 1 minus v square multiplied by d square u over d eta square is equal to sine u. So this become d square u over d eta square is equal to sine u over 1 minus v square. This is equation number 5. Now multiply equation 5 by 2 du over d eta. So equation 5 become 2 du over d eta multiplied by d square u over d eta square is equal to 2 du over d eta multiplied by sine u over 1 minus v square. So this equation can be written as d over d eta multiplied by du over d eta whole square is equal to minus 2 over 1 minus v square d over d eta multiplied by cos u. As if we take derivative of this equation, we will again get above equation. Now integrate above equation with respect to eta. So this become du over d eta whole square is equal to minus 2 cos u over 1 minus v square plus a, where a is constants of integration. A is constants. So square root of above equation become du over d eta is equal to square root a minus 2 cos u over 1 minus v square. Now take common square root 2 over 1 minus v square. So above equation become du over d eta is equal to square root 2 over 1 minus v square multiplied by square root 1 minus v square over 2 multiplied by a minus cos u. This is equation number 6. This whole term is equal to some constant. So let 1 minus b square over 2 multiplied by a is equal to some other constant which is b. So equation 6 become du over d eta is equal to square root 2 over 1 minus b square root b minus cos u. So this become du over square root b minus cos u is equal to square root 2 over 1 minus b square d eta. Let b is equal to some constant which is 1. So this become du over square root 1 minus cos u is equal to square root 2 over 1 minus b square d eta. Since we know 1 minus cos theta over 2 is equal to sine square theta by 2. So square root 1 minus cos theta is equal to square root 2 sine theta by 2. So equation 7 become du over under root 2 sine u over 2 is equal to under root 2 over 1 minus b square d eta. This is equation number 8. Equation 8 become du over sine u over 2 is equal to 2 over under root 1 minus b square d eta. Now integrate above equation. So this become integral u naught to u du over sine u by 2 is equal to integral from eta naught to eta 2 over square root 1 minus b square d eta. So this become 2 ln tan u by 4 from u naught to u is equal to 2 over square root 1 minus b square eta from eta naught to eta. So this 2 and this 2 is cancelled out. So this become ln tan u over 4 over tan u naught over 4 is equal to 1 over square root 1 minus b square eta minus eta naught. So if we take antilog, so this become tan u by 4 over tan u naught over 4 is equal to exponent eta minus eta naught over square root 1 minus v square. This is equation number 9. So equation 9 become tangent u by 4 is equal to tangent u naught by 4 multiplied by exponent eta minus eta naught over square root 1 minus v square. So this is equal to u is equal to 4 tangent inverse tan u naught by 4 exponent eta minus eta naught over 1 minus square root 1 minus v square, and eta is equal to x minus vt, and eta naught is equal to x naught minus v t naught. So u is equal to 4 tangent inverse tangent u naught by 4 exponent x minus x naught minus v t plus v t naught over 1 minus square root 1 minus v square. So this is required solution of sine-Gordon equation.